Welcome, this is Algebra 1, Semester 1, Unit 4.5, Section 7.4. We're solving linear systems by elimination. This is part 2. Yesterday we did some of this. How would you solve a system of linear equations by multiplying? You need to come back and answer this question at the end of the notes today. Be prepared to explain it tomorrow in class. The other question is, can you analyze the difference between systems with no solution and those with infinitely many solutions? How can you tell which is which? Well, let's just remember from graphing that no solutions were when they did not cross and they were parallel. So that's no solution. So they have no point of intersection. Now, infinitely many solutions, go ahead and draw that. Draw what infinitely many look like. If you're adding arrow tips here and here, that's perfect. They are the same line. That is infinitely many solutions. And they are the same line. Now, from yesterday's work, and today in class you should have worked with some. What did you see in the equations that happened? Should be for both of these. It eliminates both variables. That's what tells you that you've got one or the other, is that both variables eliminate. Now what happens on parallel is that you end up with two numbers that are not equal. You'll have a number here, let's say like 3 and 5, and they're not equal. It could be any numbers, I'm just making those up. They're never equal when they're in no solution. When you have infinitely many solutions, you end up with a true statement, like 5 equals 5. Could be any number, but it's equal to itself. Okay, can you use elimination method to solve these linear systems? Well, if we look at these, we are lined up. Our y's are over our y's, x is over the x, but we do not have opposites. Today, what we need to do is multiply to get opposites. Now, in order to get the x's to be opposites, this would have to be a 2. In order to get the y's to be opposites, our lowest common denominator of 5 and 2 would be 10, so we'd have to get 10 there and maybe a negative 10 there. By far the easiest one would be to just multiply this by 2 so that we eliminate our x's. So we're going to distribute 2 times x is 2x, write it down here. 2 times 5y is 10y. So we've distributed there and there. 2 times 10 is 20. So now we distributed there. 2x plus negative 2x wipes out. 2y plus 10y is 12y. 20 plus 4 is 24. Get the y alone, divide by 12 on each side, and we find that y equals 2. Now, we circled that, that's where we get the y answer, but remember our answer is truly a point. So we have to write the 2 in as a point. Now we take this 2 value, plug it into one of these two equations for the y value and solve for x. I'm going to plug it into that first equation. X plus 5 times 2 instead of y equals 10. X plus 10 equals 10. We could look at that and say, well, it's going to be 0. Go ahead and finish off the algebra. Subtract 10 from each side. X equals 0. Here's our true answer, 0, 2. Okay, so that's simply taking and multiplying an entire equation in order to eliminate one of your variable values. If we look at this one, In order to eliminate our x's, well, 6 would be our common denominator. So we'd have to multiply this one by 3 and this one by 2, and one of them by a negative, because they are not opposites. Our lowest common multiple for 3 and 5, the lowest thing that they'll both go into, is 15. So we'd need to multiply the top equation by 5, the bottom equation by 3. You can do either one of those. It's totally up to you. I like to keep mine small, so for the video I'm going to show you with the 6. I'm going to choose to multiply this top one by -3 to get -6, and I'll multiply the bottom one by +2 to get +6. You always want them to be opposites. So -3 times 2x would be a -6x. -3 times 3y is a -9y. -3 times 17, you might say, oh, I'm not sure on that. Just come over and multiply it. 21, 51. So it is a -51. Now on the bottom, we have 2 times 3x is 6x. 2 times 5y is 10y. 2 times 27, again, you may say, I don't know what that is. Come over and multiply it. 2 times 27, 14. 2 times 2 is 4, plus 1 is 5, so 54. Now we add these together because these x's will eliminate. And that's why we use that whole method, was to eliminate those x's. -9 and a +10 would be a +1y, or just y. 54 and a -51 is 3. So we know that our y value is 3. Now we plug that 3 back into one of these equations. I'll just use the first one, 2x plus 3y equals 17. And I'll plug 3 in for the y value. I get 2x plus 9 equals 17. Subtract 9 from each side. I get 2x equals 8. X equals 4. And my point is 4 for the x value, 3 for the y value. That is the answer, or the solution, for those two lines. They cross at 4, 3. Okay, we're on to page 9. Can you explain how you know whether one elimination versus substitution to solve a system of equations? Well, remember, for substitution, it's easiest if a variable is isolated. That's when it's easiest to use. Okay? Graphing we use just as an approximation. I know it didn't ask on that, but graphing is just an approximate answer. And then we use elimination all the rest of the time, just because it's fairly quick to use. So when we get down to this next one, we can see these 3's, positive and negative 3's, are lined up, so elimination would be perfect. It says we do not need to solve these systems, just write elimination or substitution. So we would just write elimination. And on this one, substitution would be perfect because we can plug that 2y value in right there for x. Right here we have the x isolated. So that one is perfect for substitution. Okay, go back and answer the question at the beginning of these notes, and be prepared to discuss that when you come into class. We'll see you tomorrow in class. Enjoy your evening.